So hello guys, welcome to my YouTube channel. In this video, we are going to learn about data preparation and its essential steps. We will learn how to add indexes, how to address misleading data, the expressing categorical field values, and numerical field standardization, and outlier detections. Okay, so first start with adding indexes. Why do we need to add indexes? Indexes make it easier to access and manipulate rows in a dataset. They are often unique identifiers for each row. So now let's look at the example. First, we are writing statement import pandas as PD. Then we are creating a sample data frame which is created using pd.dataframe name, and we are giving names Alice, Bob, Charlie, and another column age. Then we are printing data. Then we are adding an index field. First, we are adding it using insert keyword dot insert, and this is the starting value. This is the column name index, and we are providing its range. Then we are then we are adding indexes using using another method, which is we are adding another column order ID, and then we are simply using range keyword. So now let's copy and paste it in our Jupyter notebook. Okay, so now you can see I have pasted the code here. We are creating a sample data frame, and then we are adding an index field using data.insert, and we are adding one more time using order ID. Now let's run it and see the output. Okay, so as you can see, first output we are getting data which was the simple format, uh, name and age. Then we are getting output with index 1, 2, 3, name, age. Then we have another method by simply adding order ID, which is here. So now let's see how to correct misleading values. Full screen. Correcting field values. Incorrect values can skew your analysis, review data for errors, inconsistencies, or misleading entries. Let's see in a code. We are creating a data frame, status, active, inactive, active, and unknown. Here, unknown is an misleading values. We can try to replace it with another value, which is either if we don't know, we can replace it with active or inactive. So let's copy and paste it in a Jupyter notebook. We have created a data frame and we are printing the data, and then we have replaced the missing value, which is unknown, by active, or we can also replace it by inac- inactive. Okay, now we are running the code. हमने छोटा सा इंडेंटेशन एरर आ गया है, तो इंडेंटेशन अब करके फिर से रन करते हैं, चल जाएगा. Okay. So now you can see the output. First the status was active, inactive, active, unknown. Now we have replaced the unknown with inactive. Now let's move further. Now data preparation, the expressing categorical field values, transforming categorical fields into a more suitable format for analysis. This could involve combining categories or creating new ones. Now let's have look at the example code. First we are importing the pandas library, then we are creating a sample data frame with a gender column and age column. Now we need to map M to male and F to female. As we can see, uh, in gender column we are using F and M, and now we need to change it and map M to male and F to female. So we will be doing this with the help of map. So let's copy and paste in our Jupyter notebook. So this is the sample data frame with name, gender, and age columns, and we are using F and M for gender, and now we need to map M to male and F to female. So let's try to run it. Okay, now you can see that it is done successfully. Now let's move further. Now we will see how to standardize numerical fields. Standardization ensures that all numerical fields have a similar scale. Common methods include Z-score normalization and min-max scaling. Let's have a look at the example. We are importing pandas as PD and from sklearn.preprocessing import standard scaler. Okay, so this is a utility which is used for uh, scaling, standardizing features. Now we are creating a sample data frame. Then we are creating a standard scalar instance which is used to fit transform the data and standardize the data. We are passing the height and weight and then printing the standardized data frame. It's copy and paste. Now, as you can see, we are creating a sample data frame, creating a standard scalar instance, and then transforming the data. Let's run it. This is the standardized data. So let's move further. Now, how to identify outliers and why do we need to identify? Outliers can significantly influence our analysis. They may represent errors or unusual cases and should be investigated or removed. One method which is we use is the Z-score method, which identifies outliers by measuring how many standard deviations a data point is from the mean. So let's look at the sample code. We are creating sample data using np.random.normal, which generates 100 sample random numbers. And now we are adding outliers manually and we have given the name to the variable as data with outliers and np.append add some outliers. We are adding 5, 6, minus 5. Okay, so now we will calculate the z-score using np.mean and standard deviation using np.std and then z-score using data with outliers minus mean upon standard deviation. This is the formula for calculating z-score. Now, a rough rule says that we use the common threshold value as 3 for identifying the outliers. And outliers we will calculate by using np.where np.absolute z scores greater than threshold. It means that if outliers value is greater than 3 or less than minus 3, it will be considered as outlier. And then we are printing the outliers. Let's have a look at the Jupyter notebook. This is our sample data and we are adding outliers manually. Then we are calculating mean standard deviation and z-score using using this formula. And then we are calculating the outliers. If it is greater than 3 or less than minus 3, it will be considered as outlier. As you can see, we have got the output outliers 5, 6, and minus 5, which we have added manually. Now let's move back. So now we have learned how to identify outliers, and that's it for now. We are looking you in the next video. Thank you for watching.